It works on my machine. 4 words that have haunted every developer. The code runs perfectly on your laptop, then falls over the moment it hits a server. Containers exist to kill that sentence forever by packaging your app together with its entire environment so it runs identically everywhere. In this deep dive, we'll run real containers on AWS with ECS and Fargate, and we'll do the one demo almost every tutorial skips, the 2 IAM rules that break your very first deployment. The whole thing is just a shipping port, so let's walk the docs. First, what actually is a container versus a virtual machine, because beginners think a container is just a tiny VM. It isn't. A virtual machine ships the whole truck, your app, its libraries, and an entire guest operating system every single time, that's gigabytes, and it boots in minutes. A container ships only the standardized box, your app and its libraries, while sharing the host kernel, that's megabytes, and it starts in seconds. Quick Docker recap, an image is the blueprint you build, and a container is a running instance of that blueprint. Build once, run anywhere. So where do your container images live inside AWS? In ECR, the Elastic Container Registry. This is your own private warehouse of container blueprints. The real workflow is 3 commands: log in with get login password piped into Docker login, then Docker tag your image, then Docker push it up here. Unlike the public Docker Hub, ECR is private, controlled by IAM, and sits in the same region as your server, so pulls are fast. Think of it as dropping your stamped, versioned containers at your own dockyard before they ever set sail. Now the ECS vocabulary, which every tutorial uses interchangeably and confuses everyone. Picture the port. The cluster is the whole terminal. The task definition is the packing manifest. It lists the image, how much CPU and memory, which ports open, the roles, and where logs go, and it's versioned, like manifest version 1, 2, 3. A task is one actual running container at sea, a live instance of that manifest. And a service is the schedule that guarantees, always keep, say, 3 tasks sailing, replacing any that sink. ECS itself is the port operator placing containers onto ships. The single biggest mix-up, the task definition, is the recipe. A task is the running thing. ECS gives you 2 launch types, and the real question is, who owns the ships? This is the Create Cluster screen, and you can see the infrastructure options. With the EC2 launch type, you own the vessels, you run and patch the EC2 instances yourself, and you pay for the whole instance even if your containers only half fill it. With Fargate, you rent container slots and own no ship at all. AWS provides and runs the host, and you just pick the CPU and memory each task needs. For most people starting out, the answer is Fargate, no servers to manage. So that's what we'll use. Here's where it all gets wired together, the task definition. On this screen, you give it a family name, choose the launch type, Fargate, and the operating system. Then you pick the task size, CPU, and memory, here 1 vCPU and a few gigabytes. You add a container, point it at your image URL from ECR, and open its port. And critically, this is where you'll attach the 2 roles and the log configuration, which we'll get to next, because that's exactly where first deployments break. This is you filling out the packing manifest for your container. With the manifest ready, you need somewhere to run it and something to keep it running. This is the ECS console. You create a cluster, the terminal, and then inside it you create a service. The service is the magic. You set a desired count of, say, 2 tasks, and ECS guarantees 2 are always running. Kill a task, and the service immediately launches a replacement. You don't lift a finger. That's the shipping line guaranteeing 2 ships are always on the water, replacing any that go down. A one-off task just dies. A service keeps your app alive. Now the centerpiece, the single biggest reason your first container won't start, and almost no tutorial explains it. There are 2 completely different IAM roles. The task execution role is the crane operator's badge. It's used by the ECS agent, not your code, to pull your image from ECR and write logs to CloudWatch. Miss it, and you get the dreaded cannot pull container error and no logs. The task role is the cargo's customs permit. It's used by your application code to call services like S3 or DynamoDB. Miss it, and your running app gets access denied. The crane lifting the box is the execution role. Your cargo clearing customs is the task role. Mixing these up is the #1 beginner failure. That directly explains logging. In the task definition, you set the awslogs driver and point it at a CloudWatch log group. Now here's the insight. When your task starts but you see no logs at all, your app probably isn't broken. It's almost always the execution role missing CloudWatch logs permission, or a missing log group. So before you debug your code, check the execution role. The port files paperwork for every container, but only if the crane operator's badge lets it. Networking trips up a lot of people. ECS Fargate uses awsvpc mode, which means every task gets its own elastic network interface and its own security group, clean isolation. The professional pattern is to put your tasks in private subnets with a public application load balancer out front. And here's the classic trap that makes a task silently fail to start. A task in a private subnet with no NAT gateway and no VPC endpoint cannot reach ECR to pull its image. So if your private task won't start, that's usually why. Harbor Pilot out front ships docs safely in the inner harbor. So how does traffic reach a task when every deployment gets it a new IP address? You never point at the IP, you put an application load balancer in front of the service. The ALB has a target group, and the service automatically registers and deregisters its tasks as they come and go. The load balancer runs health checks and only routes traffic to healthy tasks. It's the harbor dispatcher, sending trucks only to the ships that have room and have passed inspection, never to one that's failing. Containers really shine when they scale automatically. On the service, you attach a target tracking autoscaling policy, for example, keep average CPU at 60%, or scale on ALB request count per target. When load rises, ECS launches more tasks. When it falls, it removes them. You set a sensible minimum and maximum so you never over-provision or starve under traffic. It's the shipping line, adding ships at peak season and mothballing them when the docks go quiet, capacity that follows demand. Secrets, the right way. Do not hardcode database passwords or API keys as plain text environment variables in your task definition. Anyone who can read the task def can read them. Instead, store them in Secrets Manager or SSM parameter store, and reference them in the task definition secrets block, which injects them at runtime. And remember, reading that secret is a permission on the execution rule, the crane operator's badge. It's a sealed diplomatic pouch, not the password scrawled on the side of the box. Let's be honest about cost, because Fargate surprises people. With Fargate, you pay per task by the vCPU second and gigabyte second, and there is no meaningful always free tier, so an idle but always on task quietly bills 24/7. The EC2 launch type makes you run the instances, and you pay for the whole instance even when half empty, but it wins at high, steady utilization. The traps, an ALB and a NAT gateway both cost money even at zero traffic, and over-provisioned CPU and memory multiply your bill. Right-size your tasks, renting slots is cheaper, until you'd fill a whole ship every single day. So when should you even use ECS? Here's the four-way decision. For short, event-driven functions under 15 minutes, use Lambda. For long-running containers with minimal operations, use ECS on Fargate, the sweet spot for most apps. When you specifically need Kubernetes for portability or an existing K8s ecosystem, use EKS. And when you need full control of the host operating system, use plain EC2. Rent a slot, run your own Kubernetes port, or hire a courier per errand, pick the one that matches the job. Let's dock the whole model. A container is the standardized box, your app plus its environment. ECR is your warehouse of versioned images. The task definition is the packing manifest. A task is one running container, a service keeps N of them sailing. Fargate means renting slots with no ship to own. And the two roles you must never confuse, the execution role is the crane operator's badge to pull the image and write logs, while the task role is your cargo's customs permit for what the app can call. And don't forget teardown, delete the service, the cluster, the load balancer, and the NAT gateway so your bill drops back to nearly zero. Get the port, and containers stop being scary. Each service gets its own deep dive, so subscribe to Vion Cloud and we'll keep making